they are receptors. Okay? Or like they are receptor targeting drugs. Again ha, most ng drugs nga atong matakol sa pharmacology, most of them are receptor targeting drugs, kumbaga. Okay, and there are a lot, many drugs available in the market that specifically targets this type of regulatory protein. Remember ha, this is a type of regulatory protein, si receptor. Okay, so isa siyang macromolecule. Okay, now sabi ko nga, since halos lahat ng drug are receptor targeting, it would be necessary nga we build first foundation on the concepts of receptor. And you have to understand first, ano yung mga different types of receptors. Alright? Now, when we talk about receptors, these are macro molecule. Kasi isa siyang type of protein, di ba? And you all know that protein, isa siyang macro molecule. Particularly, it is a macromolecule, very important for chemical signaling. Okay, very important siya for chemical signaling. As defined in this slide, these are functional macromolecule or macromolecular cell components. Okay, and take note na merong specific stereochemical configuration. Say for instance, this is a receptor. Lahat ng receptor, they have that specific stereo chemical configuration. Ito yung tinatawag na active site. Okay, ito yung active site or yung binding site of a receptor. Okay, and take note, each receptor in general, each receptor is highly specific. That is one character ng mga receptor na very highly specific sila, highly selective sila, meaning each of the receptors will only bind with a ligand na merong particular structure of its active site. Okay? So dili tanan klase ng mga endogenous substance or exogenous substance kayang mag-bind sa kahit saang receptor. Si receptor tamili siya. Okay, ang iyaharang ipabind sa iyahang self is yung mismong ligand na merong ding particular structure with its active site. Okay, now when we say ligands naman, ayan, ligands. Pag sinabing ligands, ito naman yung tawag natin sa mga molecules that actively binds to the receptors. Okay, so general term siya. Okay, and in most of the pharmacology references, ang ligands in general, they are referring to drugs. Basta kayo magbasa mo mga pharmacology references, basta makabasa mo og ligands, they are actually referring to drugs in general. Okay? And of course, you all know already that drugs are of exogenous source. Okay? Wala namang drugs na naturally produce sa katawan. Diba? But then again, hindi lang naman drugs ang may ability to interact to our body or to interact to the receptor producing an effect. Diba? I have mentioned last time, now we also have these biologic, mga natural substances produced by our body na may also interact with receptors, okay, inside our body, resulting to a unique biological response. Okay, so example doon are the ligands na endogenous source. We have the neurotransmitters. Okay, neurotransmitters, ito yung mga chemical signals, okay, or chemicals responsible for transmission, okay, transmission of signals. Again, ang mga neurotransmitters, di ba, from the term itself, neurotransmitters. So these are chemicals responsible for transmission of signals. Okay, so very much involved ni sila sa physiology ng nervous system. Okay, don't worry, we will have a more detailed discussion on neurotransmitter as soon as we will tackle the pharmacology on the drugs that affects nervous system. But to give you an example ng neurotransmitter, for example, we have norepinephrine. I think naka-encounter naman mo aning a word. This is an example of a neuro transmitter, ang norepinephrine. We also have, let's say, acetylcholine. Okay. Another is glutamate. Also, serotonin. Okay, serotonin or chemically known as 5-hydroxytryptamine. Okay. These are particularly examples of excitatory neurotransmitters. Excitatory na siya. Excitatory neurotransmitters. So, ibig sabihin, pag sinabing excitatory, these neurotransmitters they facilitates the transmission of signals. Okay? So, few examples lang ni sila sa excitatory neurotransmitter. Opposite ng excitatory, napod tayo ginatawag na inhibitory. No? Inhibitory neurotransmitter. So, example lang, we have the GABA or the gamma. You can search on the internet for the spelling. The gamma aminobutyric acid. Okay, particularly, ito yung main inhibitory neurotransmitter ng brain. Okay, then we also have another common nga inhibitory neurotransmitter is si glycine. Ito naman yung main inhibitory neurotransmitter sa spinal cord. Okay, so take note ha. These are examples. All of these are examples of neurotransmitters. Okay, and you will all get to learn all these neurotransmitters under again sa pharmacology of autonomic nervous system and central nervous system drugs. Okay, we will tackle all of this. Ano yung response nila, saan sila ng mga receptors nagbabind, etc. etc. Okay, so again, for now, just remember these are examples of endogenous substances or endogenous ligands that may interact to receptors. Okay, another example, we also have hormones. Okay, we also have hormones. And finally, the otacoids. Okay, na-mention ko na to, di ba, yung mga endogenous substances, compounds that may also interact sa body producing an effect. Otacoids, these are also known as local hormones. Okay, again, these are also known as local hormones. Mnemonics natin dito para madali lang matandaan yung mga otacoids nga substances is BESH. Okay, ano yung ibig sabihin ng BESH? Paki-take note, we have bradykinin. Ibang kulay na lang, bradykinin. Okay. E for eicosanoids. I have introduced already one example of eicosanoid. Eicosanoid, ito yung tawag sa metabolites ng arachidonic acid. No? After metabolism of arachidonic acid, as an eicosanoic acid, it will produce eicosanoids. Example, yung prostaglandins. What else? Prostacyclin, thromboxane. Ayun. Okay, S for serotonin. And again, chemical name, okay, ng serotonin is 5-hydroxytryptamine. Okay, masanay na kayo ha, basta yung ko serotonin 5-HT, lagi na akong ginasulat. Yang chemical name na siya, 5-hydroxytryptamine. Okay, then H for histamine. Okay, so these are examples of otacoids. Okay, again, we have 4 of these endogenous substances considered as otacoids. And again, we have a separate discussion of otacoids. If you'll try to check your course outline, it is under Unit 3, I think. So we will discuss all of this. Ilahang action again, ilahang responses, unsa nga mga drugs, okay, that may act just like this. Okay, mga otacoids. So for now, again, just know that otacoids are also an example of endogenous substances. Okay, endogenous ligands. All right? Okay. Again, ligands that interacts to receptors, they could be either exogenous, okay, exogenous source, and this is the most common, ha, ang mga exogenous source. Example doon, mga drugs. Or, ang ligand na pwedeng mag-interact sa receptor, pwede ding endogenous source. Okay, so example doon, neurotransmitters, hormones, and otacoids. Alright? Now, when we talk about ligand, okay? Ayan. When we talk about ligand interacting sa receptor or a ligand receptor interaction, ayan, ligand receptor interaction. So you have a ligand, example in a form of drug, interacting to a receptor, particularly to the active site ng receptor, it would be much easier na inyuha siyang dumduman using this theory, the lock and key fashion. Okay? Amo man gina-permi di ba sa receptor gani nga concept, lock and key theory. Okay, so example in this illustrated figure. Ayan. So we have the receptor. For instance ha, ito yung receptor. Ako i-arrow. Ayan. So yan yung receptor. And it is being embedded on an effector cell. Diba? So you have a receptor embedded sa effector cell. And as mentioned earlier, sabi ko kanina, diba, ang receptor, they are highly selective. Knowing na each of the receptor have that specific stereochemical configuration wherein ang ligand with a particular structure will actively bind into. So in this case, having these highly selective nga property of receptor, it will act as the lock here. Okay, mo na yung dumduman. Si receptor will act as the lock. And of course, the ligand in a form of drug, for instance, will act as the key. Siya naman yung key. Ibig sabihin siya yung susi. Okay, susi or yung key para ma-activate, no, yung receptor. Or pwede din namang ma-inhibit yung action ng receptor. Depende kasi yan. Depende yan sa signal na dala-dala ng drug, okay, or ng ligand na ide-detect naman ng receptor. Dili tanan drug mo activate og receptor. That is why we have that so-called nga mga blockers. Example, beta blockers, histamine blockers, ganon. Okay, so dili tanan. Ligands, example, mga drugs, can activate, can stimulate a receptor. Pwede din na mag-inhibit sila ng action ng receptor. Depende sa signal na dala-dala ng drug. Alright? So, once yung drug, itong drug na to, actively binds now to the receptor, particularly to the active site ng receptor, it will now form this drug-receptor complex or a ligand-receptor complex. Okay, meaning kapag may complex na, kapag may complex na between a drug and a receptor, most probably, that receptor now receives the signal brought about by the drug, okay? Or brought about by the ligand in a form of a drug, okay? So, mo gina siya always, basta nanay drug receptor complex, automatic, ma-receive na gyud ni receptor. Diba? Receptor, somehow, mo na siya word nga, recipient. Recipient mo receive gyud siya. Siya tig-receive. Okay? So in this case, si receptor yung nagre-receive ng signal brought by the drug in this given illustration. Okay? And most of the receptor, take note, most of the receptor, they somehow signal the recognition of that bounded ligand by initiating series of reactions. Okay? That is known as signal transduction. So, dili diretso. Although na ay mga effect na agad-agad yung response, but in between that drug receptor complex, then the effect or response produced, naasa na signal transduction nga mahitabo. Okay? Signal transduction. Ibig sabihin yung drug, okay, as the signal, the receptor as the signal detector, meaning it will detect or receive the signal brought by the drug. Okay, it will later on transduce that particular signal. How it will transduce or transmit that particular signal? Through initiating series of reactions. Pag nananay series of reaction, that will ultimately result to a specific response, okay? Or biological intracellular response. Okay? So again si drug, siya yung signal, i-detect yan ni receptor. Okay, the moment na na-receive na niya yung signal, it will then transduce. Okay, transmit. Okay, those signal through let's say alteration of physical or chemical properties of that particular cell, na series of chemical reaction, then ultimately it will result to a specific response. Okay, so that is all about a drug or a ligand receptor complex. Ligand, this is a general term. Okay, general term yung ligand. So yung binigay na example dito is a drug receptor interaction. Another illustration that would explain that concept of a drug receptor interaction is this one. Ayan. So for example, yung unang illustration. So wala pang occupied ligand sa receptor. So unoccupied pa si receptor. So obviously, it does not influence any cellular processes. Wala mahitabo gyud. Okay? But on the second figure, you already have a receptor. Ayan, ito yung receptor with its active site. Ito yung active site niya, yung stereochemical configuration niya. Then once it is being bounded by a ligand, sa example, in a form of a drug, okay, it will now be activated. Okay, ma-activate yung receptor. So pag ma-activate siya, magkakaroon ng alteration of physical, chemical properties of that cellular molecule. Okay, magkakaroon ng transmission, transduction of signal, producing now the unique response, okay, or biological effect. Okay, so that is the concept of a drug or ligand receptor interaction. Now, there are different, ang daming klase ng receptors, no? But always take note good nga each of the receptors will only have a specific binding ligand. Okay, producing a unique response. Tamili gid kayo siya, highly selective. Naara gid na siya yung mga particular nga mga substances na iyang dawaton. Okay? Okay, then iya day nang i-interpret, okay, ang signal iyahang i-transmit, transduce, producing that particular effect. Mo unsa man gani ang natural effect of that particular receptor. Okay? And also take note na yung magnitude ng response, ibig sabihin ng magnitude, di ba, yung extent. Kung unsa ka kusgon, okay? Yung extent ng response, yung extent ng effect being produced, that is proportional, directly proportional to the number of drug receptor complex. Ibig sabihin, the greater the number of drug that actively binds to that receptors, or the more drug receptor complexes na nabuo, the greater is the effect. No? Greater yung effect, greater yung magnitude ng response being produced. Okay? So that is all about the receptor concepts. Okay? Now, we actually have four types of receptors. Okay, so naatay four types of receptors. These are the following. We have type 1, the ligand-gated ion channel. Type 2, ito yung G protein coupled receptor, yung GPCR. Okay, usually abbreviated siya as GPCR sa mga references. Type 3, ito naman yung enzyme linked receptor. Kasi di ba kinase in general, this is an example of an enzyme. And usually yung mga receptors under this example sa type 3 are kinase linked. Kaya in some other references, yung type 3 is also known as kinase linked receptors. Okay? Then type 4, gene transcription linked receptors, or ito yung nuclear receptor. So we will discuss each. Okay, discuss natin each of these types. Okay, then I will also give specific examples in each particular type of receptors. And for some other specific examples ng receptors, there are also list of drugs no that target that particular receptor. But for now, at least you will understand bitaw what is each of this type of receptor and unsay mga example no under this type. Okay, so let's begin with type 1. Unsa dining type 1 receptors. They are also known as ionotropic receptors or the ligand gated ion channel. Again ha, type 1, also known as ionotropic receptors or the ligand gated ion channel. Okay, now these receptors are usually located on the cellular membrane. Okay, take note of its location. Kani nga mga receptor embedded sa cellular membrane, just like the usual na mga receptors, di ba? Most of the receptors, they are embedded. They are found in the cell membrane of the cell. Okay? And take note, it has a faster, okay, onset of action. Kasi sabi dito, yung onset is milliseconds. Bilis nun, di ba? Pag milliseconds, meaning once ang usa ka ligand, example, a drug, binds to this type of receptor, a type 1 receptor, ang bilis ng response. Bali, sobra kadali lang mag-receive, mag-transduce ng signal yung receptor, producing an effect. Okay, so yan yung ibig sabihin ng onset dito. Okay, yung response ba niya ba? Okay, so sobrang bilis. Now, ano yung difference ng voltage gated ion channel sa ligand gated ion channel? Maybe some of you might be asking, no? Unsa ditong voltage gated ion channel nga usa ka type nga regulatory protein. They're actually different, no? Different yung voltage gated ion channel sa ligand gated ion channel. Unang-una, yung voltage, 'di ba yung voltage gated ion channel? Yes, isa siyang regulatory protein. Okay, 'di ba? Isa siyang regulatory protein, part siya ng apat. Okay, una 'di ba doon is si voltage gated followed by the carrier molecules, enzymes, tsaka the receptors. So isa siyang regulatory protein. Kaso, hindi siya receptor. So yan yung pinakaunang difference nila. Hindi naman siya receptor. So kana pa lang, different na gud sila. Kay kung may yung tag-receptor, ano ba yung kailangan na criteria para maging receptor? Kailangan meron siyang stereochemical configuration. Kumbaga meron siyang active site. Okay? Para doon mag-bind yung ligand, 'di ba? Para makapag-transduce ng signal producing an effect. Now, if you recall, a voltage-gated ion channel, 'di ba, isa lang siyang passage ng ions. Mura siya gate. Okay, channel, so passage ng ions. Isa siyang gate na nag-o-open or nagko-close transiently in response of a voltage. Okay, in response of a cell after depolarization. Okay, so pag may na-feel na uh, stimulation yung cell, mag-o-open yung uh, gate na yon for voltage-gated ion channel. Pag sinabing depolarization, di ba somehow may changes ng charge ng cell. Most specifically, nagiging positively charging inside ng cell. That is equivalent to a voltage. Di ba? Pag may ka-voltage, somehow mura siya electrical signal. Di, mura siya positive, negative. Okay, so pag may response, pag may voltage na na-feel yung cell, that's the time nag-o-open yung voltage-gated ion channel. Say for example, si sodium ion channel, okay, as soon as mo open ang ion channel na to, it will let the influx of this permeable ion sodium entering the cell. Okay? So in here, hindi na kailangan ng binding ligand. 'Di ba? Kasi wala naman siyang active site. 'Di ba? Wala may active site nga atong makita sa voltage-gated ion channel. Kasi nga hindi siya receptor in the first place. Okay? Unlike ligand-gated ion channel. Ion channel din siya, yes. So naa kay makita nga ion channel. Example, sodium ion. Okay, sodium ion channel, potassium ion channel. Kaso nga lang, this time, yung gate niya, okay, yung passage niya, it opens or closes in response naman of a binding ligand. Right? Usually, ang binding ligand involved here are neurotransmitters. These are the most common, ha? Usually, ang ga-involve gyud nga mga binding ligand sa mga ligand-gated ion channel are in the form of neurotransmitters. Ano yung example ng neurotransmitters? Diba? Sabi ko, acetylcholine, ano pa, GABA, serotonin, etc. Okay? So say for example, specific example ng ligand-gated ion channel. We have the nicotinic receptor, or this is also known as nicotinic neural, okay, receptor. So particularly, this is located sa ganglion ng sympathetic, parasympathetic nervous system. Don't worry, yung mga terms na yon, you will all learn that sa ANS drugs. Okay, so specific example lang ng type 1 receptor, we have nicotinic receptor. Okay, and since acetylcholine, okay, acetylcholine po yung ligand that actively binds on this specific type of receptors, okay, that is why it is also called as nicotinic acetylcholine receptor. Okay, now in the given illustration, try to look at the given illustration, ha. In the illustration, di ba, you have this sodium. You have that sodium ion channel. Okay, so isa siyang ion channel. Okay, merong sodium ion channel. Now, this sodium ion channel, it opens lang. Okay, it opens in response of a binding acetylcholine. Okay, so dili na siya ma-open basta-basta kung walay acetylcholine nga mo bind on that particular receptor. Okay, on that particular nicotinic receptor. Okay, so the moment makapag-bind yung ligand in a form of acetylcholine sa nicotinic receptor, that will cause influx, no? Influx of permeable ion na sodium across the cell membrane. Okay? So, yan yung difference ng ligand-gated ion channel sa voltage-gated ion channel. Okay? Again, si voltage, yung gate niya, yung ion channel na to, it transiently opens lang in response of a voltage. Walang involved na ligand. Pag sinabing ligand-gated ion channel, okay, you have an ion channel, Okay, but it is gated with a ligand. Kailangan meron munang mag-actively bind na ligand, usually in a form of neurotransmitter, so that yung particular na ion channel na yon, it will um, open, okay, right away. Then it will cause influx ng permeable ion. Alright? So that is for a specific example ng type 1 receptor. So we have nicotinic receptor. Let's have another. So list of other examples ng type 1 receptors. We have the GABA A receptor. So isa din siyang type 1. Okay, ligand-gated ion channel din yan. Specifically, itong ion channel na to, it will open in response of a binding neurotransmitter na GABA. Di ba? GABA receptor man siya. Therefore, kaninga klase nga ligand-gated ion channel, GABA naman or gamma aminobutyric acid naman yung neurotransmitter that actively binds on this receptor. And recall, GABA is an example of a neurotransmitter, particularly ito yung main inhibitory neurotransmitter ng brain. Alright, we also have another example. We have glycine receptor. So this is also type 1 receptor. Okay, by the name of the receptor itself, you can conclude na yung neurotransmitter naman that binds actively on its site is yung glycine. Di ba? So glycine again, siya yung main inhibitory neurotransmitter ng spinal cord. Okay, GABA, siya yung sa brain, inhibitory neurotransmitter, glycine, siya yung spinal cord na main inhibitory neurotransmitter. And glycine receptors, GABA A receptors, type 1 receptors, na example. Another is the serotonin 3 receptors, okay, or the 5-HT3 receptor. So obviously, yung ligand naman na involved in this activation of this ion channel is the serotonin. Okay? So again, these four are few of the most common nga examples ng type 1 receptors, or also known as ligand-gated ion channel. Actually, madali lang kabisaduhin ang mga type 1 receptor kasi 'di ba, most of their names, they are based on the binding ligand. Okay? Usually in the form of neurotransmitters. For GABA receptor, you have GABA. Glycine, the same with glycine receptor, serotonin receptor. So based on the binding ligand. For nicotinic receptor is acetylcholine. All right. And under each of the specific type of type 1 receptors, under each, these are the examples of drugs that could target, particularly the specific receptors. Okay, so for now, at least you familiarize, okay, these drugs nga. For nicotinic receptor, we have this activators, blockers of nicotinic receptor. For GABA, we have these activators, glycine, ito yung mga example ng blockers niya. For serotonin, we have the cetron drugs that block serotonin 3 receptors. Okay, i-familiarize lang muna yung mga examples ng drugs. Yung much more focus nyo dapat is ano yung type 1 and ano yung example ng type 1 receptor, specific examples ng type 1 receptors. Kasi all of these drugs, yung lahat ng drugs na yan, ato manang discuss in detail sa ilahang specific nga pharmacology. Example, kaning mga drugs that affects nicotinic receptor, ato na siyang matakol sa ANS drugs. Ito, yung mga drugs that activates GABA receptors, that is under CNS drugs, including the blocker of glycine receptor. For serotonin 3 blockers, this is obviously under otacoids kasi si otacoid, andun yung serotonin. Example yun ng otacoid, di ba, si serotonin. So we will tackle all of this later on. Okay? So ato sang humanon yun ang basic principles ng pharmacology. Okay, let's proceed now to type 2. Okay, so yun yung type 1 ha, ligand-gated ion channel. And usually, most of the examples are based on the names of the binding ligand. Okay, so example, GABA, glycine, serotonin receptor, and also nicotinic acetylcholine receptor. Okay, now let's proceed to type 2 receptors. Type 2 receptors, these are also known naman as metabotropic receptors. Okay, or the G protein coupled receptors. So the same with type 1, ang iyahang location is found on the cellular membrane. Okay, so it is also found on the cellular membrane, embedded on the cell membrane, and faster din yung onset of action niya. Okay, faster yung onset kasi seconds lang. Within seconds, ayun na, may onset of response na for metabotropic receptors. Okay? Now, once ang isang receptor is being coupled with a G protein, okay, during a drug receptor interaction or ligand receptor interaction, yung G protein, okay, yung G protein na being coupled sa receptor na yun, it will initially release a secondary messenger. Okay? So, hindi siya yung usual na receptor lang na kapag form na ng drug receptor complex, signal transduction agad, then effect. Okay? Pag sinabing G protein coupled receptor, ang receptor na yan, it is being coupled with a protein known as G protein. Okay? Now, once ma-activate yung receptor na yan, coupled with a G protein, etong G protein na to will release a secondary messenger. Okay? And yung secondary messenger na yan, that will eventually cause series of reaction. It will produce signal transduction. Then finally, producing a unique response or effect. Now, ano ba yung mga secondary messengers na yan? Okay? Now, when we say secondary messengers, these are very small nga mga molecules, no? Or this could be in a form of ions that is able to transmit signal. Okay? They transmit signal from the receptor. Okay? Transmits signal. Okay? From the receptors towards the effector proteins. Ayan. Again ha, ang secondary messengers, these are very tiny, small molecules nga able to transmit signals mula sa receptor, towards that effector proteins. So, di ba, from the term itself, secondary messenger. So, isa silang messengers, pero secondary one. Bakit secondary one? Kasi di ba, ang drug, hindi naman nagbabind yung drug sa secondary messenger. Okay? Or hindi nagbabind yung drug sa mismong G protein. Yung drug or a ligand, it will actively bind to the special configuration ng receptor. So, ang unang makaka-receive talaga ng signal is si receptor. Tama? Then for a G protein coupled receptor, yung na-detect na signal ni receptor, okay, ipapasa niya yan kay secondary, okay, messengers. Okay? ipapasa niya yan kay secondary messenger. So yung mga secondary messengers na yan, sila yung nag-receive na ng signal from the receptor, and that messengers, that secondary messengers, they will transmit then the signal towards the effector proteins producing an effect. Okay? That is why kung imo i-compare ang onset, no, onset of response ng type 1 tsaka type 2, medyo may dili gyud grabe ka delay, no? Mas paspas gyud gihapon ang type 1. Okay, wala na may G protein, wala namang release ng secondary messenger, tapos si secondary messenger siya pa yung transmit ng message towards the effector proteins. Okay, so si type 2 somehow within seconds yung effect. Pero faster gihapon na siya kay hello seconds, 'di ba? Okay, so faster gihapon nga onset. Pero kung imo compare lang kay type 1, type 2 somehow much more faster gid si type 1. Okay? So what are examples of the secondary messengers being released by these receptors? Okay, nga G protein coupled. Example of these secondary messengers are the CAMP, no, the cyclic adenosine monophosphate. We have the CGMP, the guanosine monophosphate. We also have IP3. These are examples of secondary messengers. Okay, so again in general, ang ginagawa nila, after receiving the signal from the receptor, tinatransmit nila yung signal towards the effector protein. Okay, now with CAMP and CGMP, both actually have the same extent of signaling. Okay? Halos the same lang yung signaling nila. Okay, ng CAMP tsaka CGMP. Only that, yung CAMP, much more versatile siya. Okay? More versatile ang CAMP. Di ba kung ka versatile, sobrang diverse. Okay? Yung nagagawa niya sa body. Again, yung CAMP much more versatile siya on its action and effects sa body natin. Sobrang diverse yung action nito sa katawan natin. Whereas yung CGMP na secondary messenger naman, dili siya ganun ka-versatile like CAMP, much more isolated yung action niya sa smooth muscle. Okay, smooth muscles or particularly yung mga vessels. Okay, vascular, yung vascular, vascular, smooth muscles. Kamo na lang mag-spell out. Okay, vascular, smooth muscles, or sometimes sa mga intestinal mucosa. Doon involved yung mga mga receptor that is coupled with a G protein and releases a CGMP na secondary messenger, so intestinal mucosa. Okay, so again between the two, much more versatile yung CAMP, but somehow the same lang gihapon ilahang mga signaling. Okay, example si CAMP, when it has an action sa vascular smooth muscle, halos the same lang yung signaling nila, the same yung response, kumbaga. Okay, pero mas maraming action yung kayang gawin ni CAMP. And ang daming site na pwede siyang ma-produce as a secondary messenger. Then for IP3 and IP3 and drug, when they are released naman as secondary messenger from a G protein coupled receptor, tandaan lang yung result nila is increase yung intracellular na calcium. Okay? Calcium ions. Okay? And tandaan, kapag may calcium inside the cell, automatic contraction yung effect. Okay? So, yan yung tandaan nyo for IP3 and DAG, inositol triphosphate diacylglycerol. These secondary messengers, once ma-release sila, they will result to increase intracellular calcium. So, ang end result, kapag may calcium present inside the cell, that will ultimately cause contraction. Okay? So, those are examples of secondary messengers. So, again pag G protein coupled ang isang receptor, Okay? During a drug ligand receptor interaction, itong G protein na to being coupled, okay, ito, being coupled sa isang G protein type na receptor, it will initially release a secondary messenger. Okay, and that secondary messenger, siya naman yung magta-transmit ng signal. Okay, magta-transduce ng signal and finally producing a unique response. Okay? Now, kung ano yung secondary messenger that will take action or that will take part on the transmission of signal, it will depend. It will depend on the type of G protein being coupled sa receptor. Okay, so dili tanan G protein coupled nga klase nga receptor, automatic kani upat nga secondary messenger ang kaya nilang ma-release. Again ha, kapag G protein coupled ang receptor, hindi ibig sabihin lahat ng secondary messengers available, kaya niyang i-produce. Hindi. Ang secondary messenger, it will depend. Okay? Yung secondary messenger na mag-take action, mag-involve ba sa transmission of signal, it will depend sa mismong type of G protein. So, naatay tulo ka klase nga G protein being coupled sa receptor. Okay? And what are these three types of G protein being coupled sa receptors? We have the GS, the GI, and the GQ. Okay, again, we have a GS coupled nga receptor, napod tay GI protein coupled receptor, and GQ protein coupled receptor. Again, these are the three types of G proteins. So magdepende unsa nga secondary messenger ang ma-release. Depende na siya sa type of G protein being coupled sa receptor. Okay, let's discuss each type. Okay? So pag sinabing GS nga protein, okay, GS protein, take note, this type of G protein, it stimulates the enzyme adenylyl cyclase. Again ha, it's adenylyl cyclase. Again, ano yung action ng GS protein? This type of G protein, it stimulates, it activates adenylyl cyclase na enzyme. So as an enzyme, it catalyzes a particular reaction. So ano yung importance ni adenylyl cyclase? It is very important to produce CAMP. Okay, from this original source nga, adenosine triphosphate, diba? ATP is your adenosine triphosphate. So again ha, si GS protein, yung action niya is ginastimulate niya ang enzyme nga adenylyl cyclase. Okay? And ano yung importance ng enzyme na to? Very important to produce CAMP, to convert ATP to an active CAMP. And recall, in the previous slide, CAMP is an example of secondary messengers. Ibig sabihin, kapag ang isang receptor is GS protein coupled, ang secondary messenger na nare-release is CAMP. Bakit nare-release si CAMP? Gina-stimulate niya ang adenylyl cyclase enzyme. So tandaan nyo lang, S, no? GS stimulates. Okay? So kana lang, stimulates. Okay, so siya yung nagsistimulate ng AC, adenylyl cyclase. So may CAMP. So example of a GS protein coupled receptor is beta receptors, both beta 1, beta 2 receptors. Alright? Sige. Focus muna natin ha is yung ano yung type ng receptor, then ano yung specific example ng receptor. So I will just let you at least familiarize lang yung mga drugs that could target this particular receptor. Okay? Basta alam nyo nga si beta receptor isa siyang GS, protein-coupled receptor. Okay. Next, the other type of G protein coupled to a receptor is the GI protein. Okay? Pag sinabi namang GI protein, so from the letter I, no, it inhibits naman. Okay? So tandaan, pag GI, kaya niyang i-inhibit yung enzyme na adenylyl cyclase. So ano yung mangyayari? Implication sa level ng CAMP, taas ba or baba kapag na-inhibit yung adenylyl cyclase? Syempre, bababa yung level ng CAMP. Ayan. Alright? So take note, basta GI protein coupled receptor inhibits adenylyl cyclase. Okay? So inhibited yung enzyme na adenylyl cyclase, bababa yung level ng CAMP. So what are examples? Specific examples of a GI protein coupled receptor. We have dopamine 2 receptors. We have muscarinic 2 receptors. We also have the presynaptic alpha 2 receptors. Alright, so these are specific examples of a GI protein coupled receptor. Alright, and lastly, we have the GQ protein coupled receptor. Pag GQ naman, specifically, it stimulates the enzyme phospholipase C. Again, that is phospholipase C. Okay? So, para saan yung enzyme na phospholipase C? This is not for metabolism of or production ng arachidonic acid. It's phospholipase A. Si phospholipase C na isang enzyme, very important siya for the production of the secondary messengers IP3 and DAG, the inositol triphosphate and the diacyl glycerol from the source phosphatidyl inositol 4,5-biphosphate. Okay, so again, kapag ang isang receptor GQ protein coupled, ang secondary messenger being released, IP3 and DAG. Okay? And na-mention ko kanina na kapag na-release yung secondary messengers na to, ano yung net result? There is intracellular calcium ion increase. Intracellular calcium ion. Ayan. So pag may calcium inside the cell, automatic contraction. And what are examples of a receptor being coupled with a GQ protein? Example, we have the following. Alpha-1, muscarinic 1 and 3. Okay? The post-synaptic alpha-2 receptor, the histamine 1 receptor, and the vasopressin. Okay? Receptor. Okay? Vasopressin 1 particularly. Receptor. Okay? So these are examples of, specific examples ng mga receptors with or coupled with a GQ protein. Okay? Now, ito lahat ng mga receptors na to mula beta receptors, dopamine, muscarinic, alpha, histamine 1 receptor, this will actually be discussed sa next unit ng course outline ng topics natin for Pharmacology 1. This will be discussed sa ANS drugs. Okay, very important ni sila ng mga receptor for neurotransmission. Okay, so very involved sa physiology ng autonomic nervous system. So we will discuss each. Okay? From its location sa ilahang body, asa di makita si beta receptor, si dopamine receptor. That is very important, no? In order for you to understand the action of ANS drugs, we need to study first in detail ano yung beta receptor, saan siya makikita, ano yung natural response niya kapag na-activate, kapag na-inhibit. So, ganun. Okay? So, natay separate ana nga discussion sa ANS drugs na nato. Okay? Kaya mas malangay ta sa basic principles ng pharmacology kung ato pang isa-isahon ni siya. Naaman tayo separate ana nga discussion. Under siya sa ANS drugs. So, for now, familiarize lang yun. Each type of G proteins, the GS, GI, GQ, and ano yung mga specific examples nila. Okay, specific examples ng receptors. Okay, under each type of G protein coupled receptor. Now, I wanted to share the mnemonics kay medyo lisod manggid kayo na siya memorize. Kinsa ang GS, GI, and GQ. So, ako i-share akong mnemonics nga akong gigamit nga basin inyo hapong basin ma-apply, mas mapadali po ang inyong memorization. So, in order to easily classify each receptor, specific type of receptor, if it is GS, GI, GQ, ang akong ginabuhat is I simply memorize the mnemonics KISS. Kuha na siya katong mga letter na siya sa G proteins, di ba? Natay SIQ. Okay, SIQ, the GS, GI, and GQ. So ako lang gina-memorize is KISS, KICK, and 6. Okay? So ana lang ako ang gina-memorize, then magsulat dayon ko og pattern nga alpha 1, alpha 2, beta 1, beta 2, muscarinic 1, muscarinic 2, muscarinic 3. Then dito, dopamine 1, dopamine 2. Then histamine 1, also the vasopressin 1 receptor. Then histamine 2 and the vasopressin 2 receptor as well. Those are GS, protein coupled receptor. So this is how I memorize the classification ng each specific examples ng receptor. If it is GQ, GI, or GS. So simply memorize this pattern lang siguro if para sa inyo mapadali para sa ako madali gud sa ako ani nga memorization kung ako siyang inga ni nga pattern. So kung inyo i-check sa inyong sa atong previous slides, so sakto man nga si GQ mo na yung mga example and so forth. All right. Particularly for alpha 2 here, nga GI, this is the pre. Okay, synaptic kasi dalawa yung klase ng synapses na atay pre and the post synapses. Okay, so ana lang siya. So ito yung mnemonics na ginamit ko para madali ilang maklasify kung ano yung klaseng G protein being coupled to that specific example ng receptor. Alright, and again all these receptors, aaralin natin to lahat sa next unit ng course outline under ANS drugs. Okay, so I really hope nga mahuman gud nato siya next week, makastart na to sa ANS. Okay, that is actually part of prelims. Okay, pero kung dili na gud siya madala, it's okay, dili na to siya pugson. Okay? Now, for the remaining types of receptors, pata na human sa types of receptor. Di ba, upat man to ka types of receptor. Napaday, ma'am. Una pa ba type 3, napay type 4. Okay, so we have type 3. Okay, the type 3 receptors, these are also known naman as kinase linked receptor or the enzyme linked. Di ba? General, so mas general term siya, enzyme-linked receptor. So a specific term for type 3 is kinase-linked receptor. Okay? By the way, yung sa type 3 tsaka sa type 4 nga receptors, we will have a mas thorough good nga discussion of these types under endocrine system. Okay, so part naman yun sa pharmacology 2. Okay, so short overview lang sa type 3. Okay, para alam nyo kung ano yung type 3, ano yung type 4, and kuan lang, specific or common nga mga examples under each type. Okay, so for type 3 again, kinase-linked receptor. So same with type 1 and type 2. Okay, same with type 1 and type 2, location, cellular membrane. So it is embedded sa cellular membrane, cell membrane ng cell. Okay, however, take note of its onset of action. I mean, not action, onset of response. Okay, or onset to produce an effect ng receptor slower. Okay, slower yung onset niya since it takes minutes. Or usually, some other references kay minutes to hours good siya. Okay? Yung response ng receptor after being bounded with that particular ligand, ang onset of response niya is very slow. Okay? Minutes to hours. So, example of type 3 receptors or kinase-linked receptors, we have the insulin receptors, we have the insulin receptors, the platelet-derived growth factor, and the epidermal growth factor. So usually, these receptors are very important to control metabolism, very important to control growth, no? Very important for cell differentiation. Okay? So take note nyo lang, most of the common examples under type 3, very important ka mga receptors to control metabolism, growth, and cell differentiation. Differentiation. Okay? Ayan. Okay? So that is for type 3 receptors. Okay? And with regards also for a kinase enzyme, tatandaan nyo always, basta ganin ay involve nga kinase enzyme, di ba? Ang iyahang ginakatalyze nga reaction is that it transfers what group? What functional group? Any idea sa biochemistry? Kinase enzyme. Ano yung group or molecule, group ng molecule na gina-transfer niya? Wala.
Amino acid, ma'am.
Another answer. Ano yung functional group? Starts with letter P.
Phosphate,
Very
ma'am.
good. Phosphate. Okay. So, muna siya inyong dumduman. Basta gani na kinase, ang reaction yun is na i-transfer of phosphate. Yung dala-dala niya na group ni kinase is phosphate. Okay, that is why yung mismong receptor is being coupled with a phosphate group. Okay? So, ayan. And lastly, we have type 4. Okay, type 4 receptors. Take note, for type 4 receptors, ito yung only type of receptors located on the nucleus of the cell. Okay, kaya tawag din sa kanya is nuclear receptor. Okay? Again ha, siya lang yung only type of receptor that is found located in the nucleus of the cell. Okay? So, kailangan yung ligand, di ba? Yung ligand nga supposedly or destined nga mo bind sa isang type 4 receptor, kailangan pa niyang ma-diffuse into the cell. Kasi yung nucleus, hindi naman niya nakikita sa labas ng cell. Unlike cell membrane, di ba? Ang cell membrane, naaraman na siya sa membrane gid ng cell. Okay? Ang nucleus, di ba, nasa loob ng cell. So, yung ligand mismo, kailangan pa siyang mag-diffuse into the cell to interact with the receptor which is found inside the nucleus or inside the cell. Okay? Kaya ito yung may pinakamatagal na onset of response. Kasi nga, it takes hours. Diba? Or sometimes hours to days. Okay? Yung onset of response ng type 4 receptors. Okay? So, yan yung tandaan nyo about type 4 receptors. Basta na nag-involvement, di ba, sa genes, it has something to do with the inner portions ng cell natin. So, na-involvement ng nucleus. Alright? So, examples ng type 4 receptors, specific examples, we have the steroid hormone receptors, we have the thyroid hormone receptors, the vitamin D, and its derivatives. These are specific examples of type 4 receptors. Alright? So, kung titingnan nyo yung illustration on the right side, diba, you have a lipid soluble drug. Okay? Kailangan pa niyang mag-diffuse. If this is the target cell, the cell membrane, kailangan pa niyang pumasok, okay, para makapag-bind siya sa mismong receptor, okay, inside the nucleus. Ayan. Producing a biological response. So, yan yung type 4, characteristic ng type 4 receptor. Located siya inside the nucleus ng mga receptors. Okay? Kaya sobrang tagal ng onset, di ba, ng response ng mga receptors na to. So, overall, that is all about the major families of receptors. So, again, how we have four major families, 4 types of receptors. Sige, brief review. We have unang type, nakalimot na mi ma'am. It is the ligand-gated ion channel. Okay, pag ligand-gated ion channel, it regulates the flow of ions across the membranes. How? Na ay involvement dapat sa ligand, binding ligand. Okay? Para yung ion channel na yan, it will open. Okay? So, yan yung ligand-gated ion channel, and most of the names ng receptors under ligand-gated ion channel are based sa name mismo ng binding ligand, usually in a form of neurotransmitter. So, example is yung nicotinic, di ba? Acetylcholine receptor. Then, for type 2, we have the G protein coupled receptors. So, natay tulo ka klase nga G protein. The GS, GI, GQ. Magdepende kung unsa nga klase nga G protein being coupled sa receptor, kung ano yung secondary messenger that will be released. Okay? Then for type 3, we have the kinase-linked or the enzyme-linked receptor. So sabi natin, yung kinase-linked kinase na enzyme, it is very important na enzyme that is involved sa catalyzation ng mga reaction transferring a phosphate group. Kaya kung tanawin ninyo ang illustration, there is a phosphate group being coupled to a receptor. Ayan. Okay? Producing an effect. Then finally, we have type 4, the intracellular or receptor, intracellular. Sa loob pa ng cell, makikita yung mismong receptor, or this is also known as the nuclear receptor. Okay? So example, the steroid receptors. Titingnan nyo, di ba? Lahat ng, yung tatlo, yung first 3, embedded. Embedded sila sa cell membrane. But, in the case of type 4, ang mismong receptor, di ba, ito yung active site niya. Yung mismong receptor napa sa loob ng cell. Kaya so kailangan itong mismong ligand that has to bind to the active site ng receptor, kailangan pa niyang mag-diffuse sa cell. Okay? Producing then an effect. Okay? So end result nila, of course, biological response, intracellular effects. Alright? So those are the 4 families, subfamilies, major families ng receptors. Alright? You have any question about receptor concepts and its families? Okay. So, silence means yes. So, wala mi. Ay, so na question. Okay, silence means yes man. Na ay question. Wala. Or naa pa ba mo?
Ma'am,
Napa
pwede
ba?
clarification lang, ma'am,
Ah,
gamay.
yeah. Yes. Mm-mm.
Sa katong three types of G proteins, di ba na examples, ma'am? Kato sila kay mga silbi examples sa G protein coupled na receptors under ana nga type nga G proteins.
Example, beta receptor. Ana?
Yes po.
Oh,
Yes po.
yes. So, example, si beta receptor, under siya sa GS, protein-coupled receptor. Specific nga type nga G protein, coupled receptor C. Let's say, muscarinic 2, isa siyang GI, protein-coupled receptor. So, natay tulo ka klase nga G proteins. Kay magdepende man sa G protein coupled in that receptor kung unsa nga secondary messenger nga ma-release. Remember sa type 2, very dako ang role sa mga secondary messengers kay sila man ang mag transduce, 'di ba? Na sila ang secondary recipient ba sa signal being detected by the receptor. Then sila ang mag-transmit ana, producing a later on a response or an effect. So ayun.
Thank you, ma'am.
Yeah, sure. Sige. So, I think wala na yung other question. Let's proceed immediately to our next subtopic under pharmacodynamics principle. Let us have the drug-receptor interaction. So, dito, discuss natin yung mga features, yung mga characteristics ng isang particular ligand. And also, ano yung mga classification ng mga ligands? Okay, particularly, I am talking about the drugs ha, the drugs here. So, basta may ako ligand, ako yung general na ako na siya nga term for a drug. Okay? Okay. So, nabungkag siya. Ayan. So, let us have first discuss the features. Okay, ano yung mga characteristics, features ng isang particular ligand during a drug-receptor interaction. So, it actually has two major features or characteristics na dapat uh, or somehow present sa isang ligand. Okay, so una, affinity. Okay, ibig sabihin, ng affinity, ito yung ability ng isang ligand to bind. Okay, ano lang, ability to bind sa isang receptor. Okay, affinity. Okay, of course, any ligand must have that ability to bind to the active site, 'di ba, ng receptor. Bakit? Kailangan nilang mag-bind sa receptor. That is for the signal transduction to happen to produce an effect. Kaya kung wala mo bind nga ligand on that receptor, no response si receptor. Hindi siya ma-activate or either hindi siya ma-inhibit yung action niya. Alright? So that is for affinity. So lahat ng ligand nga may ability to bind a receptor should have this property, affinity. Okay? Second, a ligand could have. Okay? So meaning, meron ding intrinsic activity. So hindi lahat, pero some merong intrinsic activity. Okay? So yung intrinsic activity naman, ito yung ability of the ligand to activate the receptors. Okay? Meaning, this particular feature is a characteristic of those ligand na may ability to activate or stimulate that receptor. Okay? And then eventually, kapag na-activate niya, na-stimulate niya yung receptor na yun, that will lead to a cellular response. Okay? So, pag sinabing intrinsic activity, ability to activate. Activity, intrinsic activity, yan i-activate yung receptor. Okay? So, hindi lahat ng ligands may ganitong abilidad. Kaya naman tayong mga blockers, di ba? Na mga ligands. Okay? So, again, these are the two features na kailangan meron ang isang a particular ligand. Okay? During a drug receptor interaction. Okay? Affinity, ability to bind, intrinsic activity, ability to activate that receptor. Okay? Um, this time, because there are ligands, there are drugs na um, walang intrinsic activity. This is the reason bakit meron tayong classification of ligands. Okay, because of their differences sa intrinsic activity. Okay, so napa may time. So uh, there are actually two classification ng ligands. Okay? We have the agonist and yung isa antagonist. Okay? The activator, yung isa, the blockers. Okay? So agonist, this is the most appropriate term or pharmacological term to describe a drug that is able to activate a receptor. Okay? Agonist. Okay? Agonist, again, synonymous siya sa stimulators or activators. It's just the same. Okay? Stimulators or activators. Ayan. So pag agonist, meron siyang affinity, meron siyang intrinsic activity. Okay, so present yung dalawang feature ng isang particular ligand. Dapat meron siyang affinity, ability to bind, plus meron din siyang ability to activate the receptor. So that is intrinsic activity. Now under agonist, okay, under agonist, there are three types. Okay, we have the full agonist, meron din tayong partial agonist, and we also have this inverse agonist. All these three has the same degree of affinity. Okay? Lahat ng to na klase, types ng agonist, the same degree yung affinity nila, they only differ on the intrinsic activity. Okay? Meaning yung ability nila ba to activate, to stimulate that particular receptor, dun sila nagkakaiba. Alright? But with affinity, lahat sila. They can bind. Okay? They have that affinity towards that receptor. Now, when we say full agonist, okay, ibig sabihin, yung ability niya to activate a particular receptor, full effect, maximal effect is being attained. Let's say, for example, ang intrinsic activity, yung maximum ha, example lang, hypothetical. For instance, the maximal intrinsic activity between 0 to 1, okay, yung highest is 1. Example lang, hypothetical. Okay, for the quantal ha, quantal unit lang, example lang siya. Okay, quantal unit for intrinsic activity between 0 to 1, so 1 would be the maximal. Okay, maximal effect. Okay? Therefore, when we describe a full agonist, its intrinsic activity, okay, its intrinsic activity is 1. Ibig sabihin, na-attain niya, yung effect niya is maximal. It produces all the expected effects of that particular receptor. Okay? Kaya niyang i-produce yung full talaga na pharmacological response. Okay? Upon occupancy of that particular agonist to the receptor. Okay? So, yan yung full agonist. Pag sinabi namang partial agonist, okay? Partial agonist, say for example, again, ito yung quantal unit natin for the maximal intrinsic activity, 0 to 1. Pag sinabing partial agonist, partial lang, ibig sabihin yung intrinsic activity niya, yung ability niya to activate is greater than 0, but less than 1. Okay? Hindi aabot sa 1, Hindi din zero. So in between, no? In between 0 and 1, yung intrinsic activity niya, yung ability niya to activate that particular receptor. Okay? That is why it is considered to have a mixed agonist and antagonistic effect. Alright? So, yan yung property ng partial agonist. Okay? Meron siyang mixed nga agonist, meron din siyang antagonist effect. And pinaka-important thing na i-take note yun ninyo about partial agonist is that never ever combine a partial agonist with a full agonist. Bakit? Bakit hindi sila pwedeng i-combine? It is because yung partial agonist, the moment na ma-feel niya na merong presensya ni full agonist, it will try to compete with the action of the full agonist. It will act as antagonist. Okay? In that case. Kasi nga, meron siyang mixed agonist, meron siyang antagonist effect. Mixed agonist, antagonist effect. Alright? So say for example, this is a very common example, no, for a partial and a full agonist na interaction. Example, we have morphine. Morphine is known to be a full mu agonist. Mu, that is a receptor kung saan nagbabind yung morphine. Okay, so morphine, isa siyang full agonist. I will just finish this slide ha. Si morphine, isa siyang full mu receptor agonist. Expected nga yung effect niya is maximal. It produces all the necessary effects upon activating the mu receptor. Now, in the presence of a nalbuphine as a partial mu agonist, isa kasi siyang partial lang nga mu agonist. Okay? In the presence of a partial agonist, example, nalbuphine, it will try to compete, no? Makipagkompetensya siya with morphine, okay, sa mu receptor. Okay? Mo-compete siya with the mu receptor, causing now an antagonistic effect. It will now decrease the effect of morphine. And remember, morphine is an analgesia. Okay? Meron siyang analgesic effect. In fact, ito yung gold standard natin for designing an analgesic drug. Ang gold standard yun is si morphine. Okay? Now, since we have a partial mu agonist in the presence of a full mu agonist, antagonistic yung magiging effect. Kaya yung net result, decrease yung analgesia. Alright? So this is an example of an interaction ng partial agonist to that of a full agonist. So bawal na bawal nga i-combine, i-mix yung partial sa full. Kasi nga, para ma-avoid natin yung antagonistic effect. And lastly, we have the inverse agonist. Okay? So pag inverse agonist naman, meron din siyang ability to bind to the same receptor as agonist kasi 'di ba agonist siya. Okay? Meron siyang affinity binding on the same site kung asa nagbabind yung agonist. But yung pharmacological response niya is opposite kasi inverse. Okay? So opposite to that of agonist. Okay? In fact, yung ability niya as an inverse agonist, yung ability niya is to prevent the constitutive, yung normal nga receptor activity. Okay? In the absence of an agonist. Okay? So, yan yung activity naman ng inverse agonist. Okay? Inverse siya, opposite. The mere opposite of an agonist nga characteristic. Okay? So, unsa ang iyahang intrinsic activity? Less than 0. Okay? Hindi din siya antagonist. Kasi yung antagonist, 0 man gyud iyahang intrinsic activity. Okay? Meron din siyang intrinsic activity, si inverse agonist, pero negative value. Kumbaga, negative value yung intrinsic activity niya. Di ba pag less than 0, kung i-kuha na siya, linear graph, On the left side of 0 are negative values. So kumbaga, basta inverse agonist, given this quantal unit, it will have a negative value for its intrinsic activity. So yung pharmacologic response nyo, opposite to that of agonist. Alright? So these are the 3 types of agonists. So next session, we will proceed immediately sa pharmacokinetic principles. I will just continue recording the remaining topics. Siguro later na kung mag-record. Waits. Ayan.